I didn't want to get into it and like become liable if he was trying to hack the contract or something, because he had a pretty specific request. Knowing what the mevbot is doing in the Solidity contract is only half the battle. You actually have to know their strategy, know when it's being triggered, etc., to have that alpha.
GM everyone, my name's Dagachi, your host of Scraping Bits, and today I have the pleasure of speaking to Jon Becker, a wonderful friend of mine that has helped me get into my journey of formal verification, automated analysis. So it's great to have you on. I just want to quickly touch on what you do and who you are.
Nice. So my name is Jon Becker. I guess I'm an EVM ninja, pretty much. I kind of just deal with low-level data and Ethereum data in general, especially at my ex company, which just got acquired by Chainalysis. It was transposed data. A few years ago, last year, I built Heimdall, which is a really big EVM toolkit for decompiling contracts. So it like converts the raw bytecode, which is the only thing that's on chain really, to like a readable Solidity format. That's pretty much the idea of it.
How did you even get into building this advanced EVM toolkit specializing in bytecode analysis?
So I like started out in crypto a while back, and I wasn't really doing much with EVM. I was just looking into like little contracts. Like I made a proof of concept for recurring payments on Ethereum, like subscriptions. And then I wasn't really happy with it, to be honest. It was kind of annoying to deal with like the developer environment. At the time, there was no Foundry. It was just hard hat, and it was rough. I had to I made my own UI that basically let me develop contracts in a way that I thought was nicer. And then I started getting into a little bit of the security side of Ethereum and coding, and I was publishing some articles about, I guess it was OpenSea that really sparked it.
Yeah.
The OpenSea phishing exploit, I think. And I was trying to look at their contract and determine what actually went down.
Yeah.
But it wasn't verified. And I ran it through like Panoramics, which is the other decompiler out there, like the other main one other than Debob. And I had no idea what was happening. I wrote my article and I was like, yeah, so I think this is a switch case, but it turns out that was just the function dispatcher and I had no idea what I was talking about. After seeing how bad that decompiler was and how like much it could be improved, that's really what sparked my journey into building it. So I started with a Python version, which was pretty bad. And honestly wasn't better than what I was trying to do.
Yeah.
But I eventually ported it over to Rust, and now I'm confident to say it's one of the best ones.
Yeah, definitely. Whenever someone like mentions basically a disassembler / decompiler, they always mention Heimdall. It's kind of just grown into this, go-to kind of tool. And it's amazing. Yeah. Like it's got like 700 stars on GitHub right now, and it's killing it. You keep on making constant updates, new patches with new features, and people just love it, right? And what's the goal, like the end goal of this? Of basically why you keep on building this?
I don't really have an end goal monetarily or anything. I really just want it to be a public good that's always open source, so it's a learning resource for people as well as just there for the community, so that we can make Ethereum a little bit more transparent when it comes to contracts and stuff.
I think it's definitely important because a lot of contracts don't verify on Etherscan and you don't really know what's happening, right? And so people just put in their money blindly, and it can be like a rug pull or a scam. And something like this, the more comprehensive it is, the more transparent things can get. And ultimately, I guess it is kind of Etherscan's fault or the block explorer's fault, but tools like this basically help that and improve the space until things get fixed, right? I think it's incredibly important, and Etherscan does rely on this stuff as well in some ways.
Yeah, they do. They currently have a decompiler integrated, but it's Panoramics, which is very old, doesn't support the Chapella upgrade, so most contracts would probably fail.
What was the kind of process of getting into all of this and building Heimdall from scratch, I guess?
I used evm.codes a lot, like a lot.
Yeah.
I started with Python. I started building just a VM, like the EVM in Python, like
Mm-hmm.
in my own words, my own code. And building the EVM really helped me understand exactly what happens on the EVM.
Mm-hmm.
It's like a really very elegant kind of, but simple system where every opcode just has a specific function. It's really nice. So through building that EVM, that's kind of how I learned it.
And then how did you get into like disassembly and, you know, branch analysis and all this kind of stuff? Like you had to learn, you know, all these different like theories and techniques. I guess where did you start and how did you keep on progressing and getting into new techniques and stuff like that?
Yeah, so I started with building the EVM, and then from there, I just kind of dove in. I built the disassembler first because it's the simplest thing. You're basically just iterating over the bytecode
Mm-hmm.
and extracting it. It's not like x86 assembly or whatever, where you
Mm-hmm.
need to have 7 different arguments for each thing. It's pretty much just either it's an opcode like add or it's a push
Yeah.
with some bytes after it. Or now there's push 0, which has 0 bytes after it. So building the disassembler was really easy. It was like one of the first things I launched. I think V0.0
Mm-hmm.
or 0.1 maybe. All it had was a disassembler and some decoding modules for call data.
Mm-hmm.
Um, but yeah, so after building the EVM, building the disassembler, I started to like just jump into the decompiler. I just dove in. I had no clue what I was
It
doing.
first.
Yeah, I never went deep into compiler theory at all. Kind of just looking for patterns in the code. So I wrote a symbolic execution tool, which would basically just execute all of the bytecode or try to execute every single possible path of the bytecode.
Yeah.
So whenever it reaches like a jump I opcode, it'll take the true and the false path, which does lead to some problems
Yeah.
down the line with like dynamic jumps with
Yep. Yep.
I guess you call code or
Like cold data load.
yeah, you like code copy and then you jump.
Yeah.
And I don't support that yet because I haven't figured it out. But
Yeah, it's hard, man. Even I'm doing that. I'm doing like the same thing, but my one's private for monetary reasons. um,
nice.
but yeah, the jump I problem, the dynamic problem is extremely difficult. I've been stuck on that for a while. And like the
Yeah,
deeper you go into all this stuff, it gets even more complex. And the problems just become even harder, and you need even better solutions, but you need to do trade offs as well and design these whole architectures. Building something like a decompilation tool is an extremely challenging task. And I don't think people really understand, you know, the hurdle of really implementing everything and making something seem, well, return something readable and
yeah,
usable. It's extremely challenging.
yeah,
um,
it's very like non-deterministic. I guess it's not a straightforward task at all. You have to deal with things like compiler optimizations, bytecode obfuscation.
mhm.
You have to deal with people purposely and like deliberately trying to make your decompiler not work, like
Yeah.
the current contracts. Some of the devs told me that they purposely made sure that it didn't work on my tool.
Oh, wow.
Um, I think it was I forget who it was, but they reached out to me and they were like, "Yeah, I made sure you couldn't just run it through Heimdall and figure out the call data." It's a very tough problem to solve, and it's a pretty fun one to solve too. But
Yeah,
yeah,
yeah, for sure. It definitely keeps you occupied, to say the least. But it's so interesting that people were building. Was it? I'm assuming it was Huff.
yeah, it was in Huff, which uses I think call code copy and then dynamic jumps. They also use push 2 instead of push 4 or function signatures sometimes, which is not what I expected. So I have to
Yeah,
solve for those edge cases. There's like so many edge cases to everything.
yeah,
It's impossible.
yeah. It takes a lot of work and a lot of thinking. At least that's what it's done to me. I have like basically a notepad to deal with this stuff, and it's half full already of just like problems and solutions. And then once you think of one solution, you reach another problem, and you're like, oh wow, that previous solution doesn't actually support this new problem. You need like some more information relating to it or something around that.
Yeah, my current problem is dealing with ABI encoded data and decoding the strings on the fly
Mm.
with RLP decode. Because if you like go decompile a contract right now and you look at, let's say you just do wrapped ether,
Yeah.
you look at the name and the symbol functions that Heimdall spits out at you.
Mhm.
They both have this like really gross recursive huge if statement tree,
Yeah.
but under the hood it's actually just an RLP encode or decode. That's one of the edge cases I have to cover, and that's on my roadmap. It's one of the next things I want to do.
So I've seen people just create basically jump eyes for like just spamming them, just like spam this all these new control flows, and then it just it's just horrible to read. But yeah, the heuristics you need to add just are essential, but it's also a lot of thinking, unfortunately. But yeah, how did you get into basically like branch analysis and all this other stuff? And you're basically creating a CFG, right? And
Yeah. So that's what the symbolic execution stage does. My EVM that I wrote is actually really useful, like the fact that I wrote it myself,
yeah.
because every opcode that it executes has it's like part of a struct called a VM trace in my mind
Hmm.
and in the code. And that struct just holds like the input, output, other opcode, or not VM trace. It's called a wrapped op. It holds the input, the output, and all the operations that went into that opcode.
Hmm.
So essentially, the idea is at any point in time, you'll be able to say this call data load took 32 bytes from the call data, and then it got sent to, I don't know, an M store, and
Hmm.
then that got used later in a static call,
Yeah.
and basically that would get executed by my symbolic execution with the VM that I wrote,
Hmm.
and then it can later be analyzed and converted to a solidity like format just
Hmm.
by analyzing the inputs and outputs and stuff. So yeah, the symbolic execution stage builds the CFG by creating these, I guess it's a tree of like wrapped opcodes, and you get every single path just branches off to more VM traces. And yeah, it becomes really simple to convert things, but then you need to do a shit ton of post processing.
Yeah, a lot of computational power needs to occur, a lot of for loops.
Yeah, so like the that's also one of the biggest challenges I've ran into with generating this control flow graph
Hmm.
from bytecode, is like the recursive slash loop problem, because if the jump I sends itself back up to a previous branch and then it'll like keep going
Yeah.
forever,
You need like
and there's
a
not
circuit
a really
breaker.
good way to avoid that, because you can say, yeah, okay, if we already covered this branch, don't cover it again.
Hmm.
But then you're like going to lose out when the stack or the memory is different. You're going to be missing a ton of edge cases and branches. So
Hmm.
the way I've currently solved that is by checking if we've already covered that branch with the exact memory and call data, or
Hmm.
exact memory and stack. And that solves most of the loop problems, but anything EVM is never going to be perfect. So
Hmm.
it there's still always just loops in the wild that someone will report to me, and they'll be like, yeah, I ran this contract and it's been running for 7 days, and I thought Heimdall was supposed to be fast. But yeah, it does a lot of checks to try to break out of loops.
Hmm. Yeah, recursive loops are definitely a difficult task to basically solve. It is quite difficult because if it's going, it could loop forever, right?
Yeah.
And you need some like kind of heuristic to stop it, but you need to also check like what's being affected within that loop, right? And if you're just going to skip it when it comes back to the same destination, then you're skipping basically you're not covering like the whole code. You're skipping on a large chunk potentially, and it could be detrimental. It could be like a really crucial part of the code that you're skipping. So yeah, it's basically like building one of these. It's all just small little modules that you're kind of getting together. But I think the hardest part is getting the reconnaissance at the start, because if you don't have the right, I guess, reconnaissance in terms of basically, okay, what do I need to test? Where do I what do I need to store with each kind of opcode, and how do they all relate to each other? If you don't get that right, everything else kind of crumbles and you can't progress. At least that's what I've experienced. And I've even had to rewrite my entire thing from scratch in like the past 2 days, because exactly that, like my reconnaissance wasn't really working too well, and I found a problem that required a lot more information than what I currently had. But yeah, and you're also determining whether something is like a view function or pure or mutatable. I guess how do you go about discovering that?
Yeah, so there's heuristics for everything in the EVM basically. Heimdall aims to just be Solidity specific because there's no standard for any of these languages. Pretty much like Solidity and Viper might share a few similarities, but not at all. So basically, for view functions, you can just look at the opcodes that are executed in the tree. If you have functions that potentially modify state, like external calls or storing in storage or mstore.
But basically, anything that mutates, right, is not a part of a view function, right?
Yeah, so that's like the simplest thing you can determine. So if it touches state at all, even with like if it's a state accessing instruction,
Mm-hmm.
the function is no longer pure. And that just happens in the VM trace analysis, which is the step after symbolic execution
Right.
in my decompiler, and it is analyzing all the traces that it has and like building the actual Solidity code. So
Yeah.
it's just checking if any of the opcodes that it ran within that function are like non-pure opcodes. And it does the same for view. So pure and view, like the visibility of the function is pretty easy to determine.
Mm-hmm.
It gets harder when you're looking into payable because payable sometimes has like a different dispatcher and they'll revert early if you send ether. That's a non-payable function. So basically, I just check for a jump I that is reverting if there's any message.value sent. And if it's reverting because it has some value sent with that transaction, then we're going to assume it's a non-payable.
Another thing I've kind of like ran into while doing my stuff, which we mentioned before, was like the dynamic inputs, right? Like what bits are being used where and how can a user basically influence the contract. It's actually quite difficult to think of a solution for this, and I've been stuck on it for a while as well. But I don't know if you've kind of like touched on it at all with like the call data inputs for like Solidity, and how it can be used, even like the message.value. So you can still use message.value as even like a parameter input, right? If they use it correctly. So have you
I know
thought about
bots do that a lot. They'll send like three-way or something, and it's some variable they have to use.
exactly? Yeah. So have you thought about this at all, or like any kind of theories on how to solve this?
Theoretically, if you have the branches of all the possible executions,
Mm-hmm.
you'll see where these variables are used as parameters. I guess you just have to look at like if you're copying call data into memory,
Mm-hmm.
then you have to keep track of where it got copied in like some storage somehow.
Mm-hmm.
And then when memory is accessed, you check where that memory came from.
Mm-hmm.
So if it was like call data from 0 to 64 bytes, then you know that that's going to be used. Same thing for message.value. Like if it's being sent, like the entire message.value is being sent to some external call,
Mm-hmm.
then it'll like show up there. And it's just kind of in the way that I built the tracing and the analyzing. It just kind of happens.
Has anyone like ever approached you to basically reverse engineer a contract, or has anyone basically approached you to reverse engineer a contract for them?
Yeah, it was I guess either last year or 2 years ago. I got a DM on Twitter and some guy wanted to partner with me to decompile some mevbot.
All
And I
right.
was like, it's a fully open source tool. You can install it and decompile it yourself. And then I was like, knowing what the mevbot is doing in the Solidity contract is only half the battle. You actually have to know their strategy, know when it's being triggered, etc.,
Mm-hmm.
to have that alpha.
Yeah,
But
I
I
think.
didn't want to get into it and like become liable if he was trying to hack the contract or something because he had a pretty specific request.
Oh, right, got you. How can I mutate it to do whatever I want? How can
Yeah,
I take the money out?
that's one of the things I want to look at is like somehow determining what call data is required to reach a certain path in the CFG.
Yeah.
So like if we're going back to CURTA and it's like you want this function to return true, I I don't know if it's even possible because there's like so many parameters and whatever, but if there was some way for it to like, oh, we jump here because this value is too low, you just increase it and continue until you have valid call data,
Mm-hmm.
that would be pretty cool.
Yeah, I think that's a powerful tool, and that's actually something I'm working on. That's my latest problem, but it gets very complex when you basically use like a call data load and then 1 byte of that call data load for another call data load, and then that's where the my tracking system kind of gets like screwed up because I haven't thought of like a better way to kind of track this stuff.
Do you have a specific contract that did that?
I just write all my contracts from scratch because I've been doing it for a fair while, and well, yeah, both writing in Huff and obfuscation kind of stuff, and I want to kind of cover everything. So whatever I think of that is a possibility, I try to cover. Another interesting thing that I've seen is, are they using like bits as their variables? So in 1 byte, there's 8 bits, and then they mask basically a specific bit within the byte. Uh, this is kind of sounds weird, but basically they use 1 bit in this byte
Yeah.
as like the variable, and then basically 1 byte can contain 8 different booleans, and the position of the bit is basically the value. So I wanted to account for that, but I think it's also incredibly difficult to account for without symbolic execution, to see like what is like correct, what can pass and what's failing, right? Um,
Yeah.
I think you can do this kind of like bit tracker with Solidity because there's no nested call data loads that like one is dependent on another, and it just becomes like this whole tracking mess. But I think Solidity doesn't do like dynamic inputs like that, so it's much easier to track bits. But when you get into custom bytecode, it's, oh my god, it's a nightmare. But I think that's where the majority of like alpha and interesting things occur. So that's why we kind of like took different paths. Like I went directly bytecode analysis, and you went into like Solidity, right?
Yeah.
Yeah.
I think that's interesting. I didn't know Aave literally broke apart bytes into each bit and used it as a boolean. That's wild.
Yeah, I think this was when I was kind of learning about bit masking and bit shifting. I think a few of the people in the Huff Discord, shout out Huff Discord, were showing me like a repo of that being used, and I also learned about like different kind of combinations of bitwise operations. So there's like this one called De Morgan, and it uses ors and nots basically to do the exact same thing as an and, but it's just
Oh God,
a,
yeah.
a lot more complicated. So I was trying to account for that as well, and I think one of the solutions I came up with was checking for chained bitwise operations to see if something was being casted in some way. Um, and obviously in Solidity, that's so much easier because it's kind of a standard to use like a shift left, shift right, or just an end. But if someone's trying to obfuscate their code, they're going to use something like De Morgan or something more advanced.
I think I only handle for variable casting.
Mm.
Heimdall only handles shifts left, right. Then it uses and or bit masking as well, but it doesn't care about if you're like obfuscating your contract. I can't I can't help you.
Yeah, it gets way too hard, and it's super time consuming. But I don't know. I think that's also the fun in it, right? Like I want to occupy my mind and think of complex solutions to complex problems. I think that's where I get joy in life, at least.
Yeah,
I
me
get
too.
like so bored with basic Solidity. I like my mind just shuts down.
Got to be writing pure bytecode. Like
Exactly. Yeah.
that KFIC guy, Kefik. I don't know how to pronounce his name. The guy who made the EVM and the EVM.
Oh yeah, I
That,
saw that. And it was like writing pure bytecode, but like from
yeah,
memory. Oh
he was
man.
just like, oh, 60, 80, 60, 40.
Oh yeah.
That's as
This.
much as I know. The Solidity dispatcher start thing. I think that's
Yeah, yeah.
actually the free memory pointer.
I want to ask, like, what are some kind of common patterns you see in the Solidity compiler, or and what are like some patterns you've like basically seen while decompiling.
Yeah, so the largest pattern I've seen, like that I have unsolved, I already mentioned, was the RLP and the obby encoding stuff. That's pretty much one of them. What else? It does a lot of, like, the optimizer does a lot of weird stuff
Mhm.
with when you're setting storage. Sometimes it'll like bitwise OR it with the current value that's in storage,
Okay.
and it's kind of trippy. I don't know why it does that, to be honest, yet.
Yeah.
That's one of the patterns I also have to look at.
Hmm.
But
Reading the Solidity compiler itself would be quite useful. But
yeah, for sure.
have you done that at all?
No.
Building
I
decompilation tools without actually looking at the decompiler.
I've glanced over it very briefly, but I haven't looked into it in depth.
I think it's in C, isn't it?
Oh God. Okay, so I probably never will look at it.
Yeah, I remember I was thinking of it. I'm like, okay, what's the easiest way to understand how the compiler works? And I was like, okay, let's read the compiler. But it was in C or C++, something like that. And I was like, nope, not doing that. I'll take the hardware.
We just gotta recode in Rust, and then we're all good.
Yeah, man. I hope someone does do that. I think even doing what we do is quite interesting, like in like a career pathway choice as well. Like we can basically go into compiler dev, optimization. I think even like forward engineering as well, um, reverse engineering, and yeah, basically
Yeah.
formal verification. That's the way I've kind of gone, like the formal verification route.
Yeah, there's like so many things that go into building a tool kind of like this.
Yeah.
There's like so many paths forward you can take pretty much.
Mm.
I'm taking my first course on compilers next semester.
Oh, interesting.
It'll be fun.
Yeah, you've already kind of got a head start there, building this stuff, but
Yeah.
should
I
be
I
yeah.
knew absolutely nothing before I started this
Oh
like
yeah, same.
journey. I started with just the EVM, looking up opcodes and EVM.codes and implementing them.
Were you
And
doing like a
just
Rust? I mean, not Rust. Were you doing like Solidity before, or it was like complete scratch?
I was doing Solidity. I wrote, I think, one contract that I published was the Ethereum recurring payments, because I think subscriptions are very important to any financial ecosystem, and there's really no
Hmm.
solution for that on Ethereum yet. There was one that got proposed but never got past proposal,
Hmm.
and I just wanted to get into Ethereum, get my work out there. So I spent probably a weekend writing this contract. That was like one of my first Ethereum contracts.
Yeah, I think there's something like that called Sabler or something around those lines. By
What's it called?
recur, sorry,
What's it called?
like Sabler, Sabler. Basically, it's like reoccurring, but it's not 100% decentralized, or maybe it is now. But it basically just uses like block.timestamp and then some math to calculate, okay, total amount put in, how much time has passed, how much is zeroed, something like that.
Yeah, mine was extremely simple. It literally just wrapped ERC's transfer from,
Hmm.
and you'd approve to the contract, and either party, when the subscription was due, would be able to pay it. It was, I think, fully decentralized. You just need a front end. Started coding one, and then got distracted by Heimdall. Gave up on it.
Yeah. Building a UI for one of these tools is actually quite difficult as well. Have you done any not AI, UI stuff at all?
Um, for other
Heimdall.
things, yes, but not for Heimdall. Someone named ApeDev on Twitter made a UI for Heimdall, and it's very
Oh, really?
simple. You just, yeah, you put in the contract address,
Hmm.
and it'll spit out whatever Heimdall has at the time.
Oh, I
Um,
think I remember seeing that. Yeah.
yeah, it's called decompile.tools.
Hmm.
Uh, yeah, it stays relatively up to date with the Heimdall version.
Hmm.
So I have a release coming very soon, hopefully within the next few days. And
Hmm.
I think he picks it up almost instantly whenever I release on GitHub. He told me he set up a cron job or something to just look for updates. Yeah, it's pretty cool. It makes it a lot easier to use the tool, because if you're compiling Rust, it takes literally 10 minutes, 15 minutes to build the binary. And not many people want to trust a binary that you just download from GitHub.
Oh, yeah, for
So
sure.
I understand all that.
It could be like malware or some ransomware or something like that.
Yeah.
Speaking of ransomware and malware, have you ever like wondered about the world of outside crypto in assembly, um, and
Um,
applying like this to like Web 2 kind of stuff?
Not really. I've looked into some like x86 assembly and like Ghidra and stuff. I've tried reversing things before, but I never really fell in love with it like I did with the EVM. I'm not really sure why. I think EVM is just really simple in my mind, and now it makes sense to me. But
Mm,
if I ever did want to port or like convert to like Web 2 stuff, I don't think it would be that much of a lift to get
yeah.
back into assembly and reverse engineering stuff.
Hmm. Yeah, I think reverse engineering on Web3 is more financially incentivized because I think a lot of teams are willing to pay, or even just like basically black hats or anybody, yeah, basically anybody wanting to take money or analyze a contract to exploit it. That's the only way you can really do it if they don't have a verified contract. And if you're trying to be like a white hat, that's also a way you're gonna have to do it.
Yeah,
um,
you'd be surprised at how many like unverified exploitable. Actually, you probably wouldn't be surprised, but there's so many unverified exploitable contracts out there, just
mhm.
through things like they use message.origin and stuff like that.
Yeah, I'm pretty sure that's what Grow Capital was doing when he was doing exploits on. I think that's what he was doing. It might not have been him, to be honest, but there was like this time and period that really that's actually the thing that got me into all of this is seeing basically people attack each other in Mevland where where they were exploiting each other's binaries and just
Yeah, there was a lot of drama with that.
yeah, that was like the most interesting thing at the time for me. And I remember looking at that on Twitter. I'm like, wow, I want to get into this. And then I saw you already building it, and I was like, okay, it was probably good as well. So I started actually learning your one and then building my own alongside it. Um, and now we're both like still going. Um, I wonder if you're ever going to get into like formal verification. I think that would be a very fun kind of arc.
Yeah, I think it would be very fun too. That's like, just correct me if I'm wrong, but formal verification is like just doing math to figure out if contracts do exactly what they say they're going to do, right?
Yeah, I think it's along the lines of like, okay, is this doing what it's meant to do?
I think I would eventually look into that.
Hmm.
I tried making an audit module for Heimdall,
Hmm.
which would look for common vulnerabilities like reentrancy, just analyzing the CFG and stuff.
Yeah.
But that's not really formal verification. I think it'd be pretty interesting to look into.
Yeah, yeah. I think the closest, like the best tool out there right now is Brock's like pyrometer, where it
Yeah,
shows you like the bounds. Yeah, like the bounds would basically show you ranges of how like the upper bound and lower bound is the maximum value that can be that this basically this value can be a variable, sorry. And the lowest and highest value this variable can be, basically. And then it just goes through the whole list, kind of like a intermediate representation, using like A, B, C, all that kind of stuff as like unique values, and then going through the code like that, which is pretty interesting. And I think he's also got like taint analysis on the horizon. I'm not sure like how much they're working on that stuff, but I implemented taint analysis and it's pretty good. It's TLDR. It's basically you taint or opcode, quote unquote taint, which is like dyeing something. Like let's say you put some dye in like a water stream, and then the water stream has different pipes. You get to see where, or maybe not like dye, but let's say like a little boat, and the boat goes down the water stream, and you can see which way it goes down. And I guess the flow in this instance is basically the opcodes that are consuming that, and then you can see basically what that original tainted opcode is influencing down the line, which is very useful if you want to see, okay, for specifically what call data load is affecting what, right? And
yeah,
what M store at a specific value is affecting, other stuff. And then through that, that's how you kind of like identify what um, to target if you're analyzing something. Well, at least that's the route I've taken. It could be different. I could be wrong. It could be inefficient, but I don't really know if there's anything else.
That sounds really familiar to what the wrapped opcodes do, because you can pinpoint exactly which opcode instruction, whatever, came or gave that value to the operation you're looking at.
Mm-hmm. Yeah, symbolic. I can't speak today. Symbolic and what the hell? Symbolic analysis is super interesting, but it is also like very computationally heavy. And when you have basically like for loops and if statements, it's basically like how many, like it gets exponentially more difficult and more lengthy to compute. So let's say you have a for loop going for 10 rounds, and then for each loop you have a for loop nested inside for another 10 rounds. And then basically that's, 10 times 10. That's basically your computation. Um, but yeah, it gets quite challenging. But I guess
Yeah.
that's what symbolic analysis is. And I guess if you're doing like this bound analysis with the symbolic stuff, it lowers it quite a lot. But even then, let's say the maximum value for something is like a uint 256, and then you've got a lot of stuff to iterate over, right? And you've got to find something that will pass a require statement or something like that. Yeah, it's interesting. But I guess what is next for Heimdall on the horizon?
I have a roadmap laid out. Right now, I'm working on a new module called Snapshot, and it's going to be very similar to decompile, but with more accurate data and only on the function level. So it's going to look for all the functions in the contract, determine their types, or determine their parameter types, and then it'll report back a list of all these functions, their signatures, selectors,
Mm-hmm.
and then it'll also include things like access control. So, like, if you're not the person set in storage zero, or if you're not the address in storage zero, like
Mm-hmm.
you're not the admin, you can't call this function, and it'll do gas analysis as well to see like
Oh,
what's the
interesting.
highest, lowest, and average gas for that function. That's going to require an overhaul of my VM because my VM doesn't have dynamic gas at all.
Mm.
It just has static values. It doesn't care about warm or cool storage slots. But basically, TLDR in the module is just going to dump a list of all the functions in the contract and then tell you a lot of useful information about each function.
Mm-hmm. I think this would even be useful for like gas optimizations as well. So basically using Heimdall to see, okay, what is consuming the most gas and where can we change it? But I think,
Like
oh,
on an opcode level,
but like I guess people really want gas optimizations at a solidity level. So I wonder if that would even be useful. Um,
yeah, I know. I think it's Foundry probably has a way to measure gas as well.
yeah, yeah, it
But it
does.
would be cool if Heimdall had a way to measure the gas or the average gas that an opcode consumes for the entire like execution, I guess.
Mm-hmm.
Like it runs the execution like 100,000 times, and it's like on average this opcode got called 90,000 of the times, and you could probably remove it if you did this, and
Oh, yeah, yeah, for sure. It kind of okay, yeah. So if
that
it's
would
not
be
being
pretty cool.
used a lot, you can kind of like replace it with something else, right?
Yeah, but then you get into problems with Etherscan never verifying contracts that aren't directly coded by like or directly compiled by Solidity.
Yeah, yeah, that's a thing. So maybe alternatively, we should just work on the Solidity compiler and make it better. Just drop
Yeah, you could
everything we're doing.
probably improve it.
We should just make a Rust version, right?
Oh yeah, just compile Rust to EVM.
Hmm. I think Nascent just picked up Plotchy as well, so that they should be getting quite some new improvements. But I've spoken to quite a few people in the space, and they say the formal verification scene is quite bad. So I think definitely you should take this route and get into formal verification. I think personally, it's insanely interesting, um, and I think the upside is like way higher than what you'd think it would be because it's such a niche, right? Like
Yeah.
who wants to learn this stuff? I think I can count like 5 people, including like us, who are actively building basically these kind of tools. And from like the Huff, or maybe 6 people. But yeah, it's so hard, and it's such a missing market. Like there's nothing out there to
It's a
do.
little community of EVM hackers.
Yeah, yeah. Tooling is such a necessary thing, but it's lacking. I think
Yeah,
even I spoke to Harrison about this. Even like some kind of automated tool to find in Solidity where you can improve so it's like hyper optimized. So for example, using instead of like using storage and then storing that stored value in a memory slot in a for loop and then using that memory slot, you could like identify that, and if it's using the same value you can push it outside of the for loop, and so it can loop over just like a memory value instead, or yeah, just like that, so you're not calling the storage each time. So maybe like that would be pretty useful, or have you thought
yeah,
about doing that for like Heimdall, especially since your one's catered for
yeah. I think Heimdall is gonna stay relatively close to bytecode. So if I were to like go into analyzing just direct Solidity files, it would probably end up being a new project just to keep the scope the same. But yeah, I do think there is more of a need for people like us doing EVM stuff because formal verification can like discover any exploit in any contract.
Mhm.
It's like a very thorough and useful thing. It can even I think it can even find compiler bugs if I'm not mistaken.
Yeah, I
Which,
think you can do kind of everything if you make it the right way, right?
yeah, but it
uh,
requires a ton of work and
oh
there's so
yeah.
many edge cases.
Yeah, you basically
Like,
have to be an auditor and also know the compiler really well. You basically
oh
need
god,
to be like a jack of all trades,
compiler.
but like
Yeah.
a master at everything. Because like without knowing the compiler, you won't be able to build the fundamental, I guess, like not tools, the fundamental like groundwork. And then without knowing auditing, you won't know what to actually look for and make heuristics for, right? So you've got to do that, and then you've also got to make it efficient so it doesn't take days to to run, and it's also got to
Yeah.
find the things as well. Yeah, like my tool specifically is built for like critical findings only and unique findings. So like how does it interact? Basically, like how can I manipulate the bytecode in a way where I can select what input is being used where and what storage I can interact with and influence, and then also how can I basically take tokens from this or ether if it's even possible. I like my methodology was if the only thing that's really necessary to basically exploit something is taking the money and mutating a state, then that's all you should look for, right? Like you don't need to look for mediums or lows or any of that stuff because it's not critical. And the only thing that black hats look for are the critical things, things that can steal money. So
Yeah.
that's kind of like what I'm doing, which should be quite interesting. If it fails, then well, I've just learned a lot of stuff and I can go work for someone else, like maybe NASA
Yeah.
or something. Um, but if it's
That's one of the fun things. You can always like if your project doesn't take off or if no one uses it, it's still a learning opportunity. Like
yeah,
if no one used Heimdall, like the first Python version,
mhm.
I would still be working for transpose and now chain analysis. I would still I would have all this EVM knowledge, not to the extent I do now, but it would still have that knowledge. It'd be a great experience, and then I could move on with my life and probably find something else great to do.
Exactly. Yeah, it's such a great set of tools to learn. I think
Yeah,
anybody should really, if they want to get a thorough understanding of basically like bytecode level and basically even like learn Huff. You can learn Huff through this because I started without even knowing Huff. I was just reading like EVM codes just like you and trying to implement like my own VM. And to do that, you have to know how everything works, right? And then through that, you can learn other skills. And for me, it
yeah,
was Huff, and then I kind of specialized in that for a couple of months, just doing like contract work, and then still doing this on the side. Touching on that, how do you schedule your days? So you're working on Heimdall consistently while working your full time job. Because if you don't work on something consistently, you kind of doesn't really take off, does it?
Yeah, I think one of the main things to making a project take off is like being active and making sure you're engaging with people and like
Hmm.
putting yourself out there and getting them to actually use your product.
Hmm.
Even if it's open source and it's just a project like that you do in your free time, I think it's important to do all that. But um, basically, I work for 8 hours a day.
Nice.
And then I come home, go on a walk, go to the gym, and then any time I have left, I just pretty much work on Heimdall or other projects. During the school year, it's pretty much the same, except I have school as well.
Hmm.
So most of my work gets pushed to the weekends, and
Yeah.
most of my Heimdall work gets pushed to the weekends as well.
Sure.
But it's a fun balancing act between work, school, and Heimdall.
Yeah, passion project. Yeah, I think it would definitely be interesting to see how it all plays out in the future. Maybe someone tries to like hire you for something like that, or pay even like a VC might come along and just want to throw you money to like build it out, or like a sponsorship endorsement kind of thing. But yeah, I think you're definitely on the right path, and it's going to be exciting to see what's up next. We are getting close to the end now, but I would like to say thank you very much for coming on the podcast. I know this is your first time, and hopefully it's been a good one.
Thank you for having me.
Yeah, of course. And I think it's very insightful as well. Maybe this has inspired someone to basically pursue the path you've taken and um, basically dabble in the harder in these hard problems and try and create these solutions. Because I know when I started, I got inspired from the people I wanted to be like, and then basically tried it myself. And there wasn't a lot of content on those people talking, so I think it is very useful and very valuable for people in general if when they listen to this. Well, if they listen to this, right?
Yeah, I think if you're looking to get into EVM stuff, you should definitely do it because you're going to learn. It's going to be fun. There's a community of people who all just support each other.
Mhm.
It's pretty great.
Yeah, and I think don't be discouraged that it's just crypto. It relates to Web 2 as well, right? Like you can get it even if it doesn't like turn out well. You can always go into like malware and like analysis, or something to do with that, or working with compilers, anything. It's the world is really your oyster when you get into this kind of stuff. From or at least from my point of view.
Yeah, it's just like a niche of much bigger things.
Yeah, it's
Pretty much.
surprising how much a niche can like expand into more niches.
Yeah.
um, but yeah, man, it's been such a pleasure, and I hope you had a good time.
Yeah. It
Um,
was really fun.
I'm glad. Yeah, I hope the audience has an enjoyable time, and until the next one.